Hello, welcome to my video. If you have been following my previous video, you know that I am doing a course on Munger University. So in this video, I will discuss semester 4 PG MSc for TMU Tilkamanji Bhagalpur University and Munger University. So one by one discuss semester 4 PG syllabus for electives. First what you see this Semester 4 MSc M Physics elective papers 5 credit. So paper will be 5. And come to the next points. So here you see advanced quantum mechanics, B advanced condensed matter physics, C atmosphere physics, D biophysics, E laser and photonics, F measurement and instrumentation, G computational, H nano science, I plasma physics, J crystal physics and X-ray of crystallography, K energy science, L environment science. So one by one discuss paper. So wait and watch. So MSc M Physics EC elective course A1 Advanced Quantum Mechanics. This is my favorite papers. Theory of scattering, laboratory and center of mass. So unit first you see this. Laboratory and center of mass, reference frame, differential and total cross section, scattering, amplitude using green function, scattering by symmetric potential, partials, wave analysis, in phase shift, scattering amplitude in the term of phase shift, optical theorem, scattering by square wall, potential and perfectly rigidity, sphere boron approximations, itability applications to square wall potential and UAK WA potentials. That's next unit C. Relativity quantum mechanics, postulate of quantum mechanics, space-time descriptions of Schrodinger wave equation, Killing-Gordon equation, Drake equation, convergent from plane wave solution, Drake interpretation of negative energy, state and concept of antiparticle, spin and magnetics, moment of the electron and non-relativity direction, helicity and sterility property of gamma matrix, charge conjunction, normalizations and completeness of spinor. And unit 3 is quantum field theory, second quantizations, Lagrangian field theory, Hamilton's formulations, quantizations of a scalar field, quantizations of complex scalar and scalar Schrodinger field, Boson and fermions. Unit 4 quantum chromodynamics, 1 introduction of quantum chromodynamics quark models. Unit 5 quantum chromodynamics, 2 standard model grand unified theories. Course outcome, a student will have understand of. This is the read and the most useful books. So you here see this MC Grohil's. This is the most books for quantum mechanics for PG. But many books, Satya Prakash, S.C. Burma are most important, but this book is most important. And come to the next. So M Physics, B Advanced Condensed Matter Physics, credit 5. So here you see unit electron state, heterotree and heterofock explanation, correlations of energy scattering, plasma oscillations, dielectric function of an electron gas in a random phase approximations, limiting law and Friedel's oscillations. Unit 2 electron interaction, Linhard expression for wavelength and frequency dependent of dielectric constant, statics, screen Kohn effect. In Unit 3 is superconductivity, energy gap, copper pair, BCS theory, Bose condensation theory, and Gingerberg-Landau theory, Josephson, Jackson and its application, microscopic quantum interference, high temperature superconductivity. Unit 4 magnetism, the band model of ferromagnetism and its temperature dependence, ferromagnetism, antiferromagnetism, magnetism effect of nanomaterial. So nanomaterial science. Unit 5 dielectric property, theory of dielectric, piezoelectricity, ferroelectricity, antiferroelectricity and their application, nanostructure, ferroelectricity materials, synthesis and characterizations, principle of ferroelectric nanomaterial, multiferic and smart materials. So course outcome. At the end of this course, a student will be available basic knowledge of a crystal structure and system, understand the basic idea about the electronics properties. So solid state physics is Puri and Babur is most important. And here see this reference of the books. Many various books are here, right? So do you like most book? Buy these books. So which is like 1, 2, 3. Choose any books do like. So M physics AC. AC is atmospheric physics. So here see this. This is read course objectives. This and come to the unit 1 chapter 1. So first unit, introduction of atmospheric chemistry, general description and basic fact reason of atmosphere chemistry, composition minors, general minor constituent, cyclic of main element, chemistry of sulfur, carbon, nitrogen compound, photochemicals, pollution and aerosols. And unit 2 atmospheric photochemistry, radiation, observation of radiation energy in the atmosphere, solar radiation, compound profile, photochemistry of ionosphere, stratosphere, ozone, this is the ozone part, ozone holes, greenhouse effect and its consequence, effect of temperature. Unit 3 is here, atmospheric thermodynamics and cloud physics, atmospheric systems, application of first law of thermodynamics and air cloud main process in the atmosphere, cooling, potential temperature, adiabatics, expansions with condensation, particles, stability, convexity, instability. So unit 4 cloud physics and atmosphere electricity, classification of cloud, growth of drop by condensation, growth by collision and collections, warm rains, ice formations, snow hails and rains by ice process, ice precipitation, electric field and space charge, fundamental problem of atmosphere, electricity and thunderstorm, electricity lightings. So unit 5 is atmospheric dynamics, principal force acting on a parallel air, accelerations of air parcels, equations of motion, continuity equation, scales of motions, important features of the large scales atmospheric motions, large scales, mid-latitude circulation systems, thermal circulation, global circulation pattern, mid-latitude cyclones. So you see this course outcome. At the end of the course, a student will be able to acquire knowledge on the Earth atmosphere's governings by a physical law. So this is, read this. So suggested book references book, you see this. So this. So MSc Physics semester 4 D Biophysics credit 5. The course objective you read this. This is the informations. and first unit is here. So unit first, bioenergetics, principle of thermodynamics, redox potential and free energy sense of the reaction, biological energy transducer. Unit 2, physical techniques in the protein, nuclei, acid and polysaccharide structure analysis, UV voice spectroscopy, infrared spectroscopy, fluorescence spectroscopy, atomic observations spectroscopy, Raman spectroscopy, NMR, mass spectroscopy, circular dichroism spectroscopy, X-ray diffraction techniques, TEM and SEM. Unit 3 is configuration, principal types of differential and density gradient configurations and their applications. Chromatography, principal types, paper, TLC, affinity, long exchange gel filtrations, ZLC, HPLC, and their applications. Unit 4, chapter 4, you see this electrophoresis. Electrophoresis, principle and types of polyacrylamide, amide gel, electrophoresis, PAGE, SDS, phase agarose gel electrolysis, 2D electrolysis and their applications. And which course of 5, theoretical techniques and their application of biomolecules. Hard sphere approximations, Ramchandra plot, potential energy surface, outlines of molecular mechanics method, brief idea about semi-empirical and AB inito, quantum theoretical method, molecular charge distributions, molecular electrostatic potential and field and their uses. So at the end of this course, a student will be able to basic knowledge of biomolecular of chemistry and functions. Here you see this so reference of the books, you see this, and come to the next. So MSc Physics E11 E laser and photonics. So here are course objectives. On successful completions of this course, a student will be able to. So unit first, basic principle, laser rate equation for 3-level and 4-level system, dynamics of laser process, switching, modal lockings and modal pullings, lamp depth, hole burning, energy level and radiating, property of molecule, liquid and solid, laser amplifier, laser resonator, techniques of laser extensions. In unit 2, non-linear optical effect, harmonic generation, second harmonic generations, phase matchings, third harmonic generation, optical mixing, parametric generation, self-focusing of light, 2 photons observations, Doppler effect for 2 photon spectroscopy, laser spectroscopy. Unit 3, application of laser, fabrications of electronics component, material processing, laser communications, holography, military application, medical application, Star Wars, laser hazard and laser safety, optical amplifier, infrared optical device, laser cooling trapping. This is not net trapping, this is trapping. Unit 4, optical fiber communications, optical fiber structure, waveguide and fabrications of fiber, types of fibers and solution of Maxwell equation inside fiber, single decoordinations and attenuations in optical fibers. Unit 5 is here, Optical source ILD and PIND diode and optical detector IPD, analogs and digital optical fiber transmission system PDH, SDH, WDH technology. Course outcomes: knowledge of fundamental physics of photonics is developed to a high levels. You see this photonics. And come to the next. Reference of the books: MC. There are various books here. You read this and buy this. So MSc Physics Measurement and Instrumentations course objectives. You read this for objective and you read this also. This is important, 10 marks. So come to the first unit. So unit first is here. Basic principle: measuring instrumentations, accuracy, precision, sensitivity and resolution, scale, standard and calibrations, uncertainty of measurement and error, propagations of errors, statistical treatment of random errors, distribution function, their derivation and properties. Unit 2 is here. Transducer: temperature, pressure, vacuum, magnetic field, vibration, strain, displacement, and for transducer. Principal constructions and workings. Unit 3 is single conditioning and recovery, single level and impedance matchings, operationals, amplifier, modules for different signals, conditioning, addition, subtraction, scaling, difference and integrations, log and anti-log amplifier. Analog multiplier and application instrumentations, amplifier, signals to noise consideration, filtered phase loops, lock-in amplifiers. Unit 4 is here. You see this: digital signal processing, AD and DA converter, 7107 AD converter base DMM, embedded system, 8051 microcontroller, basic idea only, computer interfacing of science experiments. Unit 5 is computer interfacing of science, real times and offline data processing, data acquisition systems and data logger, principle and design, passive and active instrumentation with examples. And you see this course outcome. At the end of this course, the students should have had knowledge on the different experimental techniques. The students should have understood the basics of the physics involved in experiment. The students should be able to apply the concept of physics and do the interpretations and acquire the result. Reference book here. You see this and read and buy. I speak BUI, buy. Data reductions and error analysis for the physicals. You buy this. This is most favorite books. This is my favorite book. So come to my favorite topic is computational method, Z. So unit first, introduction of C, C++, Python, Java, Julia, Java programming language. This is the programming language of the computers. So you see this algorithm, structured programming, constant and variables, arithmetic expression, input and output statement, logical expression and conditional statement, iterations, function, array, string, pointer, IOS, function, files. Unit 2 is data interpretation and analysis, precautions and accuracy, error analysis, propagations of error, least square fittings, linear polynomials and non-linear regressions, goodness of fit and chi square, chi square. Test elementary probability theory, random variables, binomials, Poisson and non-normal distributions, unitary result, finite difference method, computer arithmetic normalization, floating point representations, its consequence and pitfalls, methods of finding root of equations, bisection method, Newton-Raphson methods, successive approximations method, solution of simulations algebraic equation, Gauss eliminations method, Gauss-Seidel derivatives methods. Unit 4 is here. You see numerical techniques, interpolations, Lagrangian interpolation difference tables, spline interpolations, three approximations of functions, Taylor series, numerical differentiation, numerical integrations, trapezoidal rules, Sampson's rules, numerical solution of differential equation, Euler method, Rings-Kutta method. So unit 5 is here. Some application of numerical methods in physics, largest and smallest eigenvalue, diagonalizations of matrix and inertial volume problem, two-dimensional Laplace equation, use of spreadsheet for calculation and graphs, simulations of simple physics problem, introductions of MATLAB, SCILAB, MATHE, Mathematica. So here you see this. At the end of this course, a student will be available to read this. So course outcome, see here. You see this. So references of the book here, see this. There are 4 books. You see this. And come to the next topics. So M Physics EC 1H Nano Science. So Nano Science, you see this course objectives. So unit 1 is introduction and basic principle, definition of nanomaterial property, application and scope of nanoscience, quantum size effect, electron confinement in an infinitely deep square wall, confinement in 1 and 2 dimensional wall, idea of quantum wall structure, quantum wires and quantum dot, preparations and properties, conduction electrons and dimensionally property dependent on density of state, carbon nanostructure, flutters rings structure, superconductivity in carbon 60 carbon nanotubes, synthesis and structure, electrics and mechanicals property, graphenes. Unit 2 is here, synthesis. Techniques for synthesis, top-down approach, ball millings, bottom-up approach, chemical methods of synthesis, RF, plasma and process laser techniques, biological methods, synthesis using microorganism and plant extract. Unit 3, characterizations technique, characterizations tools of nanomaterials, thermal analysis, DTA, DSC, TGA, dielectrometry, electric measurement, LCR meters, electrometers, amplifier, opticals, UV visibles, IR spectroscopy, ellipsometry, Raman photoluminescence and spectroscopy, atomic observation spectroscopy, structural characterizations, X-ray, differential meters, magnetics, characterizations, vibrating sample, magnetors, TEM, SEM, STM, FM. Unit 4 is here magnetic nanomaterial, magnetic nanoparticles, multiferics, and a smart material element idea of NEMS and nanotransistor. Unit 5 is here dielectric and multiferic materials, theory of dielectric, piezoelectric, ferroelectric, ferroelectricity and their application, nanostructure, ferroelectric materials, synthesis and characterization techniques of ferroelectricities, nanomaterials, multiferics and smart materials. So this is the topics of this nanoscience, and you see this course outcomes. At the end of this course, a student will be able to basic knowledge of nanoscience and nanotechnology. So you read this and reference of the book here. You must watch this and read this. You must read this. You should read properly. So unit I, plasma physics. Unit first, basic single particle approach, charged particle in a uniform and non-uniform electromagnetic field, plasma, the fourth state of matter, concept of electron and ion, temperature, device length, cyclotron, frequency, lemma radius, drift velocity of guiding center, magnetic moment, magnetic mirror system and their relation to the plasma confinement adiabatic invariant. Unit 2 is magnetic hydrodynamics, fluid approach, introductions to idea, MHD systems, fundamental equations of magnetic hydrodynamics, system diffusion and mobility of charged particles in a plasma, plasma as a fluid and MHD equations, approximation and linearizations of MHD from dimensional considerations, single fluid MHD equation, MHD generators. And here you see unit 3, wave and instability in plasma. Wave is unmagnetized plasma, energy transport, ion acoustics wave and MHD waves. Issue of plasma stability and use of normal modes, and analyze stability interaction between plasma particles, perturbations at tube fluid interference, raylight tensor and instability, Kelvin Helmholtz instability and Jeans instability. Unit 4 is kinetic theory. So need for kinetics theory and MHD as explanations of kinetic theory, meanings of FV, phase space for many particles motions, velocity and space distributions functions, derivation of fluid equation and electron ion plasma oscillation frequency, derivations, Landau equation of kinetic theory and Bell-Sov equation for fluid dynamics. Unit 5 is application, SA theory of thermal ionizations, application in a space science, controlled thermonuclear fusion, magnetics, resonance, dynamics, action. So course outcome, a student will have understanding of theoretical methods to study of charged particle motion, process of generate plasma in a laboratory, mechanism of plasma production, it helpful to make fusion reactor. So discover of sun, nuclear reaction and future tense, produce electricity of nuclear reactions, nuclear sun. So you see this reference of the books, you see this and read this, see and read, you look at. So come to the next point. M physics, J crystal physics and X-ray crystallographics, credit 5, You read this and come to the first unit, chapter first. So first unit is geometry of crystal, introduction, lattice crystal systems, symmetric, primitive and non-primitive cell lattice, direction and plane unit cells of CCP structure, constructing crystals and some simple ionic covalent structure. Unit 2, crystal symmetric probabilities, space group and crystal structure symmetrics of the 14 probabilitics, coordinations of probabilitics, space fillings, polyhedral 32 crystal classes, centers and inversion axis of symmetric crystal symmetrics and property translations. Symmetrics elements, Cusis, periodic crystal and crystalloids. So unit is 3 lattice representations, index, lattice, directions, lattice planes, Miller indices, zone axis, zone law, transforming Miller indices and zone axis, symbol reciprocals, lattice, vector reciprocals, lattice, unit cells. For cubic crystals, proof of some geometric relationship using reciprocal lattice vector addition rules with Jones law, D spacings of lattice. Unit 4 is X-ray diffraction. Diffraction of Black law. Diffraction method, scattering by electrons, atoms, unit cells. Introductions to X-ray electromagnetic radiation. Continuous spectrum characteristics, spectrum observations, filter production of X-ray, directions of X-ray, safety precautions, contributions of Leo, Berg and Ewald of X-ray diffraction, indexings of X-ray diffraction patterns. In 5 is crystal defect, representing crystal in projections, crystals, plane, stacking, fault and twins. Stenographics, projections, point defect lines, defect planar fault, role of dislocations in plasma, deformation and crystal growth, colored center. So you see this student would have understood the structure of various crystals. You read this and reference of the books here is, you see this 4 books. So M Physics K Energy Science, credit 5. This course will have, you read this and come to the first unit, solar energy. So first unit is solar energy, fundamental and material aspect, fundamentals of photovoltaic energy, conservation physics and material property, basics to photovoltaic energy, conservation, optical property of solid, direct and indirect transitions, semiconductors, interrelations between absorption coefficient and band gap, recombinations of carriers. Unit 2, solar energy, different types of solar cells, types of solar cell sections, solar cell transports, equations, current density, open circuit voltage and short current, brief descriptions of single crystal, silicon and organic and polymer scale cells, elementary idea of advanced solar cells, example tandem solar cells, solid liquid Jackson solar cells, nature of semiconductor, principle of electrochemical solar cells. Unit 3 is hydrogen energy, fundamental, production and storage, relevance in relations of depletions of fossils fuels, you read this, and environment considerations, solar hydrogen through photoelectrolysis, physics of material characteristics for production of solar hydrogen, brief discussions of various storage processes, a special feature of solid hydrogen storage materials, and structure and electronics characterizations of storage materials, new storage models, And unit 4 is here you see hydrogen energy and safety and utilizations. Various factors relevant of safety use of hydrogen as a fuel and use in a vehicular transport. Vehicles is the transport hydrogen for electric generations fuel cells. Various types of fuel cells, application of fuel cells, elementary concept of other hydrogen based device such as a hydride battery. For example, electric rickshaw, electric car is example of electronics, electrics hydride batteries use of the electric source. So unit 5 is other renewables, clean energy. Element of solar thermal energy, wind energy and ocean thermal energy conservation. So unit 5 other renewable clean energy. So course outcomes, the student will be able to you understand, read this, and also you read this is your useful. And reference of the books here, MP Agarwal, Solar Energy, S Chand, and various book here, 4-5 books. So M Physics L, Environment Physics, credit 5. You read this course. This course will be enables. Unit first is here you see essentials of environment physics, structure and thermodynamics of the atmosphere, compositions of air, greenhouse effect, transport of matters, energy and momentum in nature, starifications and stability of atmosphere, law of motion, hydrostatics equilibriums, general circulations of the tropics, element of weathers and climate of India. Unit 2 Solar and testicles radiation, physics of radiations, interactions of light with matters, relight and my scattering law of radiation, Kirchhoff's law, Planck's law, Beer law, Wien's displacement law, solar and testicles, ultraviolet radiation, ozone depletion problem, IR, infrared regions, observation, energy balance of the Earth atmosphere system. Unit 3 is environmental pollution and degradations, elementary fluid dynamics, diffusion, turbulence and turbulence diffusion, factor governing air, water, noise, pollutions, air and water's quality, standard water disposal, heat island effect, land and seas breeze, puffs and plums, gases and particle matter, wet and dry depositions. Unit 4 is here you see environment change and remote sensing, energy source and computations process, renewable source of energy, solar energy, wind energy, bioenergy, hydro power, fuel cells, nuclear energy, forestry, bioenergy, global. So unit 5 is here global and regional climate, elements of weathers and climate, stability and vertical motions of air, horizontal motions of the airs and waters, pressures, gradient forces, viscous forces, inertia forces, Reynolds number, enhance greenhouse effect, energy balance, a zero-dimensional greenhouse models. So you see this and see this also course outcomes. The student will be available to you read this and reference book above here you read this. So I hope this video help for your coming soon examination of PG, Munger University, TMBU and Patna University and All India University. So all related to this discussion it for today. Thank you very much and best of luck for examinations, your coming soon examinations. Thank you very much.